Good morning, students. Welcome to Bindu Dhadwal chemistry lessons. Our topic for today is physical properties of amines, and we will also discuss the basic nature of amines. So, the first few members, methylamine, dimethylamine, ethylamine, are gases, and they have smell like that of ammonia. The higher members are liquid and may have fishy smell. Still higher ones are solids. Aromatic amines are toxic in nature. Most of the amines in the pure form are colorless, but as they are easily oxidized, they become colored due to impurities and atmospheric oxidation. Amines, boiling point of amines, they have higher boiling points than hydrocarbons of comparable molecular masses. This is due to the reasons that amines are polar compounds. Nitrogen have greater electronegativity than hydrogen. So with the exception of tertiary amines, these can form hydrogen bonds with amongst themselves and get associated. So primary amines form maximum hydrogen bonds, so they are most associated. Secondary amines will form lesser hydrogen bonds, but again as for show association. Tertiary amines do not have hydrogen, so will not show association due to intermolecular hydrogen bonding between hydrogen of NH2 and nitrogen of adjacent molecule. So because of this intermolecular hydrogen bonding, greater energy is needed to break these bonds, and so boiling point is higher. However, amines have lower boiling points than those of comparable alcohols and carboxylic acids. This is because in amines, nitrogen atom has less electronegativity, 3.0, whereas in alcohols and carboxylic acids, oxygen has greater electronegativity. So OH bond in alcohol and carboxylic acids is more polar as compared to NH bond in amines. Among isomeric amines, the primary amines will have greater boiling point than secondary than tertiary, because it forms more hydrogen bonds than secondary, and tertiary forms no hydrogen bond, so it has the lowest boiling point. This has the highest boiling point. For example, primary amine, propanamine, has boiling point 323 Kelvin, methyl amine has 307 Kelvin, and trimethylamine has 276 Kelvin, lowest boiling point. Similarly, normal butylamine has 350.8, highest, ethylamine 329.3, than ethyl dimethylamine 310. Solubility. Lower aliphatic amines are soluble in water because they are capable of forming hydrogen bonds with water. However, solubility will decrease with increase in molar mass of amines due to increase in the size of hydrophobic alkyl part. Therefore, higher amines containing 6 or more carbon atoms are insoluble. Because of their weaker hydrogen bonds, the solubility of amines in water is less than those of alcohols. The nitrogen atom is less electronegative than oxygen, so forms less strong hydrogen bond. Butane 1 amine will have less solubility than butane 1-ol. The amines are also soluble in less polar solvents like ether, alcohols, or benzene. So here amines is forming hydrogen bond with water and thus are soluble. Aromatic amines are insoluble in water because the larger hydrocarbon part will mask the formation of hydrogen bonds. It tends to retard the formation of hydrogen bonds of smaller amino group. Aniline is insoluble in water. However, it's quite soluble in organic solvents such as ether, alcohols, or benzene. Chemical properties of amines. So difference in electronegativity between nitrogen and hydrogen atoms and presence of lone pair of electrons on the nitrogen atom makes amines very reactive organic compounds. So because of the presence of lone pair of electrons on nitrogen atom, amines will behave as nucleophiles. The amines can donate these electrons and act as bases. Number of hydrogen atoms attached to the amines will also decide the reactivity of the amines, the reactions of amines. So first reaction is reaction with water, basic character of amines. So amines have lone pair of electrons present on them, and because of these lone pair of electrons, they tend to donate these electrons to H plus given by water. So amines act as a base. These amines are more basic than water, so they will give electrons and accept proton from water to form ammonium salt, ammonium hydroxides, alkyl ammonium hydroxides. They are basic in nature and will release hydroxide ions when dissolved in water. This reaction is similar to that the reaction of ammonia in water. Ammonia dissolves in water to form ammonium hydroxide, which will give hydroxide ion, so it's basic in nature. Similarly, secondary amines will also form secondary ammonium salt and will release hydroxide ions. Tertiary amine will also release hydroxide ions. Due to the presence of hydroxide ions, aqueous solutions of amines are basic in nature. The basic strength can be expressed in terms of dissociation constant. This reaction is a reversible reaction, so equilibrium constant will be concentration of products upon concentration of reactants. Because concentration of water is more or less constant, it being in large amount, so when taken to this side, the product will be another constant which is known as dissociation constant of base. So this ionization constant of base will be concentration of alkyl ammonium ions into hydroxide ions upon concentration of amines. So greater the Kb value, ionization constant value, stronger will be the base. Basic strength can also be represented in terms of pKb value, where pKb is negative log of Kb. So smaller the pKb value, the greater will be the basic strength of amines. So structure, basicity, relationship of amines and comparison of basic character of amines. So basicity of an amine will depend upon the ease with which it accepts a proton from the acid to form the ammonium cation. In other words, the basic character of amine depends upon the stability of ammonium cation it forms after accepting a proton. So more stable the cation relative to the amine, more basic will be the amine. So comparison of aliphatic amines and ammonia. Aliphatic amines are stronger bases than ammonia. This is because in aliphatic amines, the alkyl group is electron releasing in nature. So it tends to intensify the density, electron density on nitrogen atom, thereby making it more available for donation or protonation. So ammonia is less basic than aliphatic amines. Aliphatic amines are stronger base than ammonia, which can be seen from the Kb value and pKb value also. Larger pKb value for ethyl amine shows that this is more basic than ammonia. Smaller pKb value of amines also shows that it's more basic than ammonia. So in ammonia, lone pair of electron is less available, whereas in aliphatic amines, because of electron releasing inductive plus I effect of alkyl groups, the lone pair is more available for protonation and for donation, so it's more basic in nature. Amine, when combines with hydrogen, will form ammonium ions. So the positive charge on the nitrogen atom is dispersed by the electron releasing effect of the alkyl group. So this is more stable than the relative amine. Anilinium ion is more stable, so reaction goes in forward direction, so it's basic in nature. Now, if we compare basic strength of primary, secondary and tertiary amines, the number of alkyl groups goes on increasing. In tertiary amines, there are 3 alkyl groups, so 3 electron releasing groups will increase its basicity to maximum. So tertiary amines will be more basic than secondary than primary, but this trend is followed in gaseous phase only. In aqueous solution, it has been observed that the tertiary amines are unexpectedly less basic than other. For example, we can see that in aqueous solutions, dimethylamine, secondary amine, will be most basic in nature than primary, than tertiary. And similarly, in ethylamines, diethylamine, secondary amine, will be more basic than tertiary, than primary. This may be explained on the basis of following factors. Steric factor. The size of alkyl group is more than that of hydrogen, so it hinders the attack. A bigger sized alkyl group will not allow the acid to approach the nitrogen atom. It will hinder the approach of acid. Tertiary will be least basic according to the steric factor. Size of alkyl group is more than that of hydrogen. It hinders the attack of acid on the amine, and therefore the basic strength decreases. This effect is called steric hindrance. According to this effect, tertiary amines should be less basic. Then solvation of ions. When amines are dissolved in water, they undergo hydration through hydrogen bonding, and the substituted ammonium cations will form hydrogen bond with a water molecule and release energy called hydration energy, and therefore get stabilized. Now, greater the extent of hydrogen bonding, more will be the stability, and consequently greater will be the tendency of amine to change into a cation. So greater will be the basic strength of corresponding amines, and stability of ammonium cation due to hydrogen bonding will depend upon the number of hydrogen atoms present on the nitrogen atom. In case of primary amine, the ammonium ion that is formed after accepting a proton will have 3 hydrogen, so it will form 3 hydrogen bonds. Secondary amine will form 2 hydrogen bonds. Tertiary amine will form only 1 hydrogen bond. So this can be shown here. Primary amine will form ammonium salt, which will form maximum 3 hydrogen bonds. Secondary amine will form less hydrogen bonds, tertiary the least. So tertiary ammonium ion is less hydrated than secondary ammonium ion, which is less hydrated than primary ammonium ion. Thus, tertiary amines have less tendency to form ammonium ions and are consequently less basic. So when we combine these factors, the order of basicity of aliphatic amine should be primary is more than secondary is more than tertiary. But the inductive order that we have done earlier was opposite. Tertiary is more basic than secondary is more. So if we combine all these factors, we get the sequence: secondary amines are more basic than tertiary amines than primary amines. So the secondary amines are having the maximum basicity. Comparison of basic strength of aromatic amines or aryl amines and aliphatic amines. So aromatic amines are less basic than aliphatic amines and ammonia. For example, ethylamine has pKb value 3.29, which is less than that of aniline. So aniline is less basic than ethylamine, aliphatic amine. Also less basic than ammonia, which has pKb value 4.75. In aniline, the NH2 group is attached to a benzene ring directly. So as a result, the unshared electron pair on nitrogen atom are in conjugation with the pi electrons of the ring. So double, alternate, single, double, single, lone pair. So we have conjugation here. And so these electrons, because they are involved in conjugation, they are less available for protonation. We can see the resonating structures of aniline. So first structure has a lone pair of electron and 3 double bonds. In the next structure, the double bonds are on alternate position, and we can construct the next structure, these electrons move here. NH2 is electron releasing in nature, so these electrons move here. So we see that the next three structures will be having positive charge on the nitrogen atom, so electrons are not available for protonation. So it is clear from these resonating structure that structure 3, 4, 5, there is a positive charge on nitrogen atom, so the lone pair of electrons become less available for protonation. So aniline is less basic than ethylamine, in which there is no such resonance. This can be understood from comparing the relative stability of anilinium ion also. Anilinium ion has only 2 resonating structures in comparison to 5 resonating structures of aniline. So as we know that resonance leads to stability, more resonance means more stability. So aniline is more stable, anilinium ion is less stable. So as the product is less stable than reactant aniline, so aniline has less tendency to get converted to anilinium ion, so it is less basic. The basic character can also be understood in terms of orbital theory. According to this theory, the p orbitals of the benzene ring can enter into conjugation with the lone pair of electrons of amine, nitrogen atom. So the pi cloud, instead of rotating around the benzene ring, gets extended. This is extended pi electron cloud. So the lone pair of electrons form a part of the pi electron cloud and are not available for protonation. So according to orbital theory also, aniline is less basic than aliphatic amines. Effect of substituents on basic character of aromatic amines. Electron donating groups will increase the availability of lone pair of electrons, and it will also disperse the positive charge on the nitrogen atom, so stabilize the anilinium cation and increase the basic strength. So the electron releasing groups such as methyl, methoxy and amino will increase the basic character of aniline. On the other hand, electron withdrawing groups like nitro, cyano or halogen atom will withdraw electrons, destabilize the anilinium cation and decrease the basic strength. So electron releasing methyl group will be causing increase in basicity. So para-methyl aniline will be more basic than aniline. And this will be more basic than para-nitroaniline because this is electron withdrawing and decreases basicity. So electron releasing groups are called activating groups. Electron withdrawing groups are called deactivating groups. Para-methyl aniline, para-methoxy-aniline and para-amino-aniline will be more basic than aniline. And para-chloroaniline, para-bromoaniline, para-cyanoaniline, para-nitroaniline will be less basic than aniline. The base weakening effect of electron withdrawing group and base strengthening effect of electron donating group is more marked at para position than at meta position. So that means that electron releasing group will make this aniline more stronger base than at meta position. So electron releasing group at para position will make it more basic than at meta position. So para-methyl aniline will be more basic than meta-methyl aniline, and this will weaken the basic nature. So para-nitroaniline will be less basic than meta-nitroaniline. Also, whether they are electron withdrawing or electron releasing are less basic than aniline. This is due to ortho effect, which is due to the combination of steric and electronic factors. So even though methyl group is electron releasing in nature, ortho-methyl aniline will be less basic than aniline. Ortho-nitroaniline will also be less basic than aniline. The base weakening effect of electron withdrawing group is very large when it is present at ortho position. So we will see that ortho-nitroaniline will be very less basic in nature. Then methyl group, when present at para position, will be giving maximum basicity. So para-methyl aniline will be more basic than meta-methyl aniline, will be more basic than aniline, will be more basic than orthomethyl aniline. And amongst nitro compounds, we see that aniline is most basic, then meta, then para, then ortho. Effect of substituents on the nitrogen atom in N-substituted amines. So an electron releasing group will increase the basic character, electron withdrawing group will decrease the basic character. So when hydrogen atom of amino group of aryl amines are replaced by electron donating alkyl groups, the basic character will increase. So a tertiary amine will be more basic than secondary, will be more basic than primary. So dimethane and dimethyl aniline is more basic than N-methyl aniline is more basic than aniline. On the other hand, when hydrogen atom is substituted by an electron withdrawing group such as phenyl, the basic character will decrease. So aniline will be more basic than N-phenyl aniline or diphenyl amine, and it will be more basic than triphenyl amine. Comparison of basic character of aryl amines. The lone pair of electrons on nitrogen atom in aniline is delocalized over the benzene ring. However, in case of aryl amines, the lone pair of electrons on nitrogen atom is not conjugated with the benzene, so it is not delocalized. Hence, the lone pair of electrons in aryl amine is still available for protonation, so it will be more basic than aromatic amine, aryl amine. So aryl amine is more basic than aryl amine. Further, aryl amines are less basic than alkyl amine, because in aryl amine this acts as an electron withdrawing group and will decrease the basicity, whereas the methyl group will act as the electron donating group and make the lone pair of electron more available for protonation, whereas C6H5 acts as electron withdrawing group and makes the lone pair of electron less available for protonation. So methylamine will be more basic than benzyl amine. That's all in today's video. If you like the video, please do share and subscribe. Thank you. Have a nice day.